Hi everybody. I was told I'm far too depressing when I start these things, so I want to make sure that I am more upbeat and put all my fake whoop-de-doo into it. So get ready for podcast 2.01. Welcome to the second chapter. This chapter is entitled Naming. So you've already started memorizing your ions, and you probably have them halfway done by now because you just finished your easy test. Today we're going to learn how to identify the type of element and the types of element we're going to deal with. Basics of bonding, charges of particles, the octet rule, and ion nomenclature. So let's go ahead and get started. Change that. There we go. Metals, nonmetals, and semimetals. So I'm going to put in a magical line in here that you should have. In your book periodic table, you can rough one out or just kind of look at this for now. You'll get one in class tomorrow. But this line is the magical border for metals, nonmetals, and semimetals. Now, if I asked you, this is the line that borders it. If I asked you what's a metal, a nonmetal, or a semimetal, I would ask you, well, name a metal. And some of the metals that you should know would be like an iron. Oops. An iron. Come on, iron. Fe. Or copper. Or something like that. Or zinc. And all of these are on the left-hand side of that stair step I've just drawn. So everything on the left of the stair step is a metal, with the important exception of hydrogen, non-metal. And this is, oh, you know what a metal is. It's a metal. Hydrogen, not a metal. The guys on the right-hand side are non-metals. And then there's the guys that are on the stair step itself. Oops. Trying to highlight here, and my things. Oh, here we go. On the stair step itself. So the ones I'm coloring in yellow are semimetals. And these semimetals all have two sides on it. The one exception to this is aluminum. If you don't know that aluminum is a metal, you've got serious problems. So aluminum is one of the metals that should first jump into your head. So the ones right on here are called semimetals, and that means they have properties of both. So if I were to ask you what potassium, K, was, you would say it's on the left-hand side, and you would call it a metal. If I were to ask you what number 16 sulfur was, you'd say it's on the right-hand side. It's a nonmetal. If I were to ask you what Sb, which is antimony, believe it or not, is, you would say, oh, two sides on the stair step. That is a semimetal. By the way, all of the guys down here are also metals in this bottom part right here. They're all metals as well. So let's quiz ourselves, I hope. What is lead? Lead symbol is Pb. Pb is right here. Oh no, I don't have that stair step in it. And I'm not going to draw it. I'm going to make you kind of see it in your mind's eye. Remember, it starts here. I guess I just said I wouldn't draw it, and I just did. And keep stair stepping down, so that means it's a metal. Silicon. Woo! Oh, I can even finish that stair step I'm not drawing. Semi-metal. By the way, silicon, Si. S is sulfur. Magnesium. On the left, metal. Hydrogen. On the left, wait a minute, that's not a metal, that's a nonmetal. That's my tricky one. Neon is Ne. The neon lights are bright on Broadway, which is a gas. Gases tend to be nonmetals. All gases are nonmetals, as a matter of fact. Americium, if I were to guess what symbol that is, I'm going to guess it's going to start with A and then have an M. Number 95 down here, all the way on the bottom. Remember, those things on the bottom are still metals. Gold, the symbol for gold is kind of hard to remember sometimes. And I don't know who told me this, but they say, hey, you, give me back my gold. Get it? A, you, give me back my gold. He. Number 79 is right here. And if you're looking to see if gold is a metal or not, shame on you. Shame on you. Shame. Ionic bonds are bonds between metals and nonmetals. An ionic bond is where you have ions that form. Atoms gain or lose electrons to form ions. So anything with a charge is an ion. Anything charged is an ion. Anything. So atoms gain or lose electrons to form ions. Cations are positive, anions are negative, and the bad way to remember this is if you have a little kitty cat, see his cute little nose, little ears. Cats are, looks like a pig. Cats are positive. See, cats have these little paws. Yeah, I guess pigs have hoofs, so. But cats are positive. So metals and nonmetals are the bond and the cause of strong attraction. So positives attract negatives. Opposites attract. Bust out with your Paula Abdul songs if you know the words. A lattice forms that's called a formula unit. So basically, if this thing's positive, it's going to attract a negative. And not just one negative, but negatives all around it. And then that negative would then attract other positives. And depending on the size and shape of the things, you get different looks for these different guys. So these are two examples of what these crystal lattices would look like. These little, I hope they're purple guys, are surrounded by the bigger green ones. So you can see how those would pack in tightly. This also shows a picture of how they can be arranged in a different way where you can see it. The sticks don't really exist. The sticks are bonds, but they help us visualize where the attractions occur. So these would be lattices. Okay? And they go on and on and on. The opposite of this would be water. I think we've talked already about how water looks like Mickey Mouse. Water is just Mickey Mouse. There is no continuing lattice. There is one molecule of water. This actually is NaCl. But NaCl, but look, I'm already counting the green ones. 1, 2, 3, 4, 5, 6 little chlorines. And so on and so on and so on. Wouldn't it be Na73Cl73? Well, we reduce it because this lattice, we just reduce it to the simplest form because we don't want to be able to have to count the atoms because counting atoms is very hard, like counting from 1 to a billion. Covalent bonds. Covalent bonds are two or more nonmetals. Electrons are shared. The prefix co means aw, share. So if you cooperate with someone, you operate sharingly. If you're a communist, you share everything and give it to the government. Okay? So covalent, electrons are shared. And actually this word valent means electrons. So covalent means share your outer electrons in bonds, which is very different than an ionic compound. Remember, ionic compounds trade them. Give me your electrons. Okay. Not share with me. Oh, I would love to share with you. No. Sharing is covalent. Ionic is trade. These form distinct molecules, not formula units. This would be one distinct molecule, just like water is one distinct molecule. Hopefully we're going to the next one. Diatomics, Knopf, Coolbree, Hat, always pair up if alone. They're desperate for company. As long as they've got a partner somewhere, they're happy. Don't forget these guys. These guys, by the way, are all molecules. Right? Because if they're, they would be two things stuck together and not forming a lattice. Metallic bonds are two or more metals. So whenever you've got just metals, you're forming a metallic bond. It's a non-directional covalent, sharing outside electrons bonds. So your electron C. So I've got these positive nuclei and I've got these negative ions around it. And these electrons are just kind of going anywhere. Woo! And they're just happy. If you're negative, you're attracted to positive things. So this is like going someplace. This would be like if you're a negative electron and you get to go to college and you're a guy and you're going to an all-girls college and they're all very, very, very attractive. Because, of course, the girls are positive because they're good and pure. The guys are negative because we're evil. We are bad. Look out for us, ladies. So there's your electron C, only it's not one electron. It's a bunch of electrons doing that same thing. Metallic bonds happen in pure elements or alloys. Remember, an alloy is a homogeneous mixture of solids. And there's metals as far as I know. What type of bond and what type of particle are magnesium chloride? We need to look at our periodic table again. So if you can get out your periodic table in your book or scroll back to the periodic table I had before. Magnesium is on the left-hand side, so it starts with a metal. And chloride is chlorine, which is Cl. And that's on the right-hand side. It's a nonmetal. So a metal and a nonmetal would be ionic. What type of particle? It would be a lattice, which is many particles, to be honest with you. Aluminum, metal, if you're looking, shame on you. Fluoride is on the right-hand side, so it's a nonmetal. Metal and a nonmetal would be an ionic bond. Type of particle would be lattice. Sulfur, nonmetal. Hexabromide, we're just going to look at the bromine. The hexa just means you have 6 of them. Bromine is Br, also on the right side, a nonmetal. Type of bond, oh, I can see them sharing already. Covalent, and type of particle would be a molecule. 14 karat gold. Is that pure gold? It's 14 karat gold, so it's not pure. But still, the type of bond is going to be metallic. And the type of particle would be, that's a good question. I don't even know what to call that. I guess they're just atoms. Yeah, they're atoms grouped by their non-directional covalent bonds. Sorry, I had to think about that. Hydrogen gas is not H. Oh, enough Coolbury H. So it's H bonded to H. Hydrogen is a nonmetal, bonded to a nonmetal. So, hydrogen sharing its electrons. Bonding is covalent, and it makes a molecule. Molecule. NH3 ammonia. Nitrogen, right-hand side, nonmetal. Hydrogen, left-hand side, but it's still nonmetal. So the type of bond is going to be, sharing again, because 2 nonmetals make sharing covalent bonds. And the type of particle would be a molecule. Water, 2 nonmetals, molecule. We talked about that enough. Sodium is Na. It's on the left-hand side. It's a metal. Acetate. Some of you know acetate already. You've memorized your ions. C2H3O2 negative. Now, you usually said a metal and a nonmetal. Well, it's true nonmetal, but this is an ion, right? So wouldn't it make sense that ions make ionic compounds? And they do. And ionic compounds form lattices. Keep on moving. Next slide. Oh no. I think it's here it came. Formula unit versus molecule. Formula unit. Type of bonding, ionic. Reduced or not? Formula unit is reduced. Watch out for non-reducers like peroxide and mercury too. So I can have an ionic compound. And things like peroxide, O2, negative 2, and mercury 1, which is Hg2 plus 2. And they never reduce. So these things will always have their 2's in there, even though they're ionic. Okay, so we talk about reducing the formula units. You don't reduce things with O2, negative 2 in it, nor Hg2 plus 2 in it. And those are the ions you're using. So my molecule, whoops, I was supposed to change colors there. My molecule would be type of bonding, covalent. Reduced? Nope. And then never reduce. Molecule. Then we have another battle. Ion versus not an ion. Ions. They're ions. They have a charge. Metals. They are atoms, not ions. Ionic compounds are made of ions, but their charge cancels. So if I asked you if an ionic compound was an ion or not, the answer is no, it is not an ion, but it's made of ions. A covalent, not an ion, and no part is an ion. Man is an island, and no covalent compound is an ion. If it has a charge, it's an ion. If your mama has a +2 charge on it, she's an ion. Don't put your ion on my mama. Come on, change the slide. Why form ions? The reason why you form ions is because all atoms have electrons, and electrons are trying to become full. I'm trying to become stable, which would be low energy. So why form ions? If you can arrange yourself so you're full, you'll be more stable, and you'll be lower energy. Full usually equals 8. That's why there's 8 columns on the periodic table. 1, 2, we ignore the middle part. 3, 4, 5, 6, 7, 8. There's 8 of these columns, so that it represents the 8 things that keep it in there. Remember, everything's on a quest for lower energy. So again, think of the wonderful baby example. Do babies want to be high energy or low energy? So think of the baby, rocking the baby to sleep. Oh, gently rocking the baby. Or do babies want to be high energy? Shaking the baby is bad. It causes permanent brain damage, and you don't get to have fun in life. You end up dead, which is bad. Never shake babies. So why form ions? Because if you gain or lose electrons, you end up with a full outer level, and full means lower energy. Charge in the periodic table. So again, you can think of each of these as having like 8 in a box of 8. This column right here would have 1 electrons, 2 electrons. Remember, we ignore all those. 3, 4, 5, 6, 7, 8. If I have 8, I never gain, nor do I lose electrons. If I have 7 electrons, and I'm more stable at 8, I would gain an electron. If I gain a negative electron, my charge becomes -1. If I have 6 and I want to get to 8, I would gain 2 negative electrons. Gain 2 negative electrons, my charge is -2. If I have 5 electrons and I want to get to 8, I would gain 3 negative electrons. And since electrons are negative, it would be 3. I'm going to hop over to the other side. Here's the 8th grade model of the atom. Woo! And somehow along the line, you had 8, 8, 8, 2 here. Okay. Now, on this first column here, instead of having an 8 in the outer shell, what you have is 1. So I'm pretending this dot is 1 electron. So if I lose this electron, the entire ring goes bye-bye. Wah! Bye-bye ring. So how many do I have in my outermost shell now? 8. So this first group can lose an electron and get to 8. That means its charge will be +1. The second column has 2 electrons in it, so it would lose 2 to get to 8 because it's easier to lose 2 than gain 6, so it is +2. Same thing right here. If I have 3 electrons, it's easier to go +3. Now, once you get to the middle part here, is it either gain 4 or lose 4? You just say, I'm not going to do it, and it's 0. So what you need to know from this slide is the first column on the periodic table is +1, +2, +3, 0, -3, -2, -1, 0. And we gain and lose electrons so that we get in our outermost shell, because 8 is full and 8 is stable. You guys are starting to learn your polyatomic ions better and better and better, and you might see some trends. There's an 8, there's an ite, there's a hypoite, and there's a per-ate, and there's some kind of stem in here. And you might think that 8 is the most common. The only thing that's really true is 8 and ite. Ite is 1 less than 8. Hypo is 2 less than 8. And per is 1 more than 8. So, for example, the most common chlor ion is chlorate, ClO3 negative. Perchlorate is 1 more oxygen, ClO4 negative. Notice the charge stays the same, it's just 1 more oxygen. Chlorite is 1 less than chlorate, ClO2, same charge, -1. And hypo, the prefix hypo actually means low. If someone is hypoglycemic, that means that they have a low blood sugar. Hypochlorate would be 2 less than the most common, so ClO negative. That's all I can give you to help with your ions. But the good news is that we are out of here in less than 20 minutes. So now kick back, relax, watch a little football on TV, and kiss your mother goodnight and tell her you love her.